In this lesson, we're going to learn how to solve quadratic equations using the completing the square method. Completing the square is another method for solving quadratic equations. Some may not use it when given a choice of methods to solve quadratics, but this general process is very helpful in future forms of mathematics, so understanding the process is very important. So let's begin with this first quadratic equation of y equals 2x squared minus 4x minus 8. Since solving a quadratic equation is basically finding the x-intercepts of the parabola that is formed by this quadratic equation, we have changed our y and set it equal to 0 because all x-intercepts have a y value of 0. And I've switched it to the right simply because for most people it's easier to work with the equal to the right. To do completing the square, though, requires us to have a 1 as the coefficient of x squared on our quadratic. So to do that, we simply need to divide everything in this quadratic on both sides of the equation by the number 2. So 2x squared becomes our x squared that we need, minus 4 divided by 2, so 2x, minus 8, that's now going to become minus 4. And even though you divide 0 by 2, you still end up with 0. Because in the case of the x-intercepts, that multiple of 2 is not going to affect us any. Now we're going to go ahead and work on the process. Step 1. Move the constant to the other side of the equal sign. So we now have x squared minus 2x equal to positive 4. So now we're going to create our perfect trinomial. To do that, I'm going to have a perfect square here at the end. So we're going to take the middle term. We're going to cut it in half. So negative 2 divided by 2, negative 1. We're going to square negative 1, and that's going to give us 1. Now we've added 1 to this side, so we need to add 1 to the other side. Now we have our format where we can now take the left side, x, minus 1 quantity squared. On the other side, we now have 4 plus 1 is 5. We're now set up to use extraction of roots, where we take the square root of both sides of the equation to solve. Take the square root of both sides. Of course, the left side, x minus 1 squared, simply leaves us with x minus 1. And we're left with the positive or minus square root 5. Now, I'm not x equals yet, so I need to add 1 to the other side, and what I really am getting is x equals 1 plus minus square root 5. This could be left because this is an exact answer. If you're asked for a decimal, you could then calculate. You will have your two answers, 1 plus the square root of 5, and then 1 minus the square root of 5. Let's complete another example. Again, I've changed y to 0. I have x squared minus 10x plus 8 equal to 0. Now my x squared already has a 1 in front of it. So I can go ahead and get started with the method by moving the 8 to the other side. So now I have x squared minus 10x equal to negative 8. So again, what we're doing now is we're going to take the middle term b, and we're going to divide it by 2. So in this case, we're taking negative 10 and dividing it by 2. And once we get that answer, we're going to square it, and that's what's going to go in this third term. So negative 2 divided by 2 is equal to negative 5, and negative 5 squared is plus 25. Now I've done it to the left. Now I need to do it to the right. So we're going to add 25 to this side. So now we go ahead and take a look here. We got our left side we can put into our form. So we have our x minus 5 squared. It's now a perfect square. Negative 8 plus 25, that's going to give us a positive 17. So now we're going to take the square root of both sides again. The left gives us x minus 5. The right gives us plus minus the square root 17. So again, we have to isolate the x by adding 5 to both sides. And that comes out to be 5 plus minus the square root 17. And again, this is an exact answer because 17 is not a perfect square. If you're asked to put it into decimal format, then you would just do the arithmetic of 5 plus whatever the square root 17, and then 5 minus the square root of 17. Now I'm going to have you try. We have y equals x squared minus 12x minus 9. I've already set it equal to 0 for you. X squared minus 12x minus 9 equals 0. Pause the video, try to work through the problem. After you've completed it, restart the video, and you can check your work against mine. Let's see how you did. So again, in this particular example, x squared has already got a 1 in front of it, so we can go straight into the method of completing the square. So the first thing you should have done was to add 9 to the other side of the equation. So you're left with x squared minus 12x equal to positive 9. Now we're going to take the left, make a perfect square out of it. So we're going to again take the middle term, negative 12, divided by 2. That's going to get me negative 6. We then square that, and our perfect square is positive 36. But again, what we added to one side, we need to do to the other. So now we have x squared minus 12x plus 36 is equal to 45. So now we'll do our left side. X minus 6 squared equals 45. We take the square root now of both sides, and we're left with x minus 6 equal to plus minus square root 45. And again, want to isolate the x. So now we have our exact answer, x equals 6 plus minus the square root 45. Now this is an exact answer. If you're doing decimals, again, you can take the square root 45. If you are required to simplify your radical, then square root 45 we know can be simplified. So simplifying the radical, if you can remember, is that you're going to take the square root 45 and break it up so that one of the factors is a perfect square. Well, we happen to know that 9 times 5 is 45. So square root 9 I can take and get 3. So this turns out to be 6 plus minus 3 square root 5 with a simplified radical. Congratulations!